Hello everybody and welcome to our presentation Control Cabinet and Switchgear Production 4.0. My name is Thomas Weichsel and I'm working as a product manager for software-based engineering solution for almost 27 years. Since 2008 I'm responsible for the ePlan solutions to improve your productivity in control cabinet production, ePlan Pro Panel and ePlan Smart Wiring. Before we go into details, I'd like to invite you to send us your questions via your chat function. We will answer them at the end of the presentation then. So let's get back to the core. Let's get back to the main question in panel building, how to increase productivity. From our point of view as solution provider, the objective is to industrialize your production process. That means to optimize it and to bring it from something, let's say, a handcrafted manufacturing level to an industrial production level. Therefore, we have to take care about several aspects, for example, about standardization. How to describe data that is necessary during the process steps and that is able to provide every process step with the required data. We have to talk about digitalization to make sure that the complete value chain can be used very smooth and the data can be provided and used from process step to process step. And last not least, we have to talk about interoperability. That means the interaction of tools and how they communicate with each other in engineering, in work preparation, in material management, but also and as well in production. So the first thing we have to do is to take care about the current process. When we take a look at this, we have to be aware that the control cabinet is one of the core components of automation and industrial automation. So alone in Europe, more than 1 million large cabinets were sold in 2017. And 75% of all these applications were ordered in a quantity of 3 down to lot size 1. So the trend towards batch size 1 is responsible for the increasing of variance and complexity of the product control cabinet. And that is something that challenges small, medium, but also large companies. Where are the challenges? Why is this a challenge? Why is complexity and the increasing variance a challenge? To answer this, we have to take a more detailed look on the process. And from my point of view, it is a little bit funny. We're talking about control cabinets, a core component of automation. Automation, as you know, is a core component of concepts like Industry 4.0 or Industrial Internet of Things. And we have to face that in many cases, the production of control cabinets is really, really far away from concepts like Industry 4.0 or IIoT. So the process in control cabinet building is still dominated by a lot of manual activities. It is depending on analog, often incomplete information that has to be interpreted, that has to be enriched, that has to be translated into manufacturing information by highly educated and specialized staff. We have to see the media breaks in the complete workflow, which leads to insulate solutions. A typical example for this is the drilling machine, which is really insulated in the panel shop, where a worker has to program manually the NC data and the machine program for the next order and to process the next part. And last not least, we have to be aware that the process in many aspects is really inefficient because of missing or incomplete data, which is not designed to support the process step in the best possible way. So to summarize, one might say that even in best-in-class companies, the production process in panel building can of course be improved. So we wanted to get more detailed in this, and therefore we made ourselves a lot of customer analysis. And in parallel, the University of Stuttgart set up a case study, a reference model to analyze the process step and to exploit where are the potentials, to identify where are the potentials that could be exploited. And we found out that in more or less all the process steps, there's a lot of potential. In material picking, because of incomplete bill of materials. in, for example, labeling because of missing or, in many cases, wrong information, depending on copy and paste concepts in the electrical engineering. We're talking about mechanical processing, where people use drawings, paper-based, to realize a layout and to program the drilling and milling machine for the next process step. And we have to face the wire prefabrication, which cannot be automated because of missing information. So last not least, one aspect is the wiring itself and the information that should be provided to the worker but cannot be provided. Facing all these aspects, we found out that currently more than or up to 40% of the entire production time of a control cabinet can be saved if it would be possible to industrialize and to automate the process in panel building. So therefore we have to take care about several aspects which are crucial for the productivity growth, for the time to market, for the quality, and last not least, for your cost evolution. So one aspect is article data. The way how we're going to integrate article data into the engineering process, how we're going to enrich article data, describe it, and provide it to be used in the downstream processes. The next part is the tools and the interaction of tools. So is it easy or not to integrate an engineering solution in your individual IT infrastructure? Is it easy to pair it with your ERP system to enrich your project data, for example, to do some calculations and some pricing? Is it easy to, for example, interface machines based on data and interfaces used in the engineering? So, and last not least, we have to think about the methods. The way we're going to describe data, the way we're going to describe our product, and how we're going to provide the necessary data for the downstream processes in work preparation, materials management, and last not least, the production itself. So the quality and the depth of data is crucial, because if the data is not defined in the required way to support the process step, it has to be generated on demand within the process by the worker who needs the data for every job, every day, again and again and again, and you can be sure this will increase your costs. So the interaction of tool is a prerequisite to define high quality data to support your process steps. The high quality data and the seamless provision of this data is a prerequisite for automated processes, and this will at least lead into cost reduction over your complete production process. So, from our point of view, we have to change the method. I already mentioned this. To change the method means, from our point of view, that the result of electrical engineering and efficient electrical engineering and work preparation should be a digital description of the product to be built. We call this the virtual prototype. The virtual prototype is a 3D model including and containing all information necessary. Bill of material, shop drawings, the assembly data to do pre-confectioning, for example, of terminal stripes, NC data so that, that you avoid the manual programming of your machines in every order. And last not least, the wiring information, which makes it possible to prefabricate your wires in the necessary lengths, with the correct labeling, with the correct and defined wire end preparation. So the virtual prototype at least provides all data required, where it's needed, when it's needed, in the necessary depth. So if you get curious how to realize this and how to save at least up to 40% of your production time, I'd like to invite you to our software demos. Helped by Mr. Sergio Brinkhaus, he will show you ePlan Pro Panel and ePlan Smart Wiring and our concepts to increase productivity in control cabinet and switchgear production. So let's get to the questions, if there are any questions. Let's have a look. There are only a few, and currently my colleagues are going to answer them. But there is one interesting. It's in your experience, which area of production has the greatest potential for optimization? It's a little bit small in here. Yeah, I would say it's clearly the wiring. The wiring of a control cabinet takes about 40% of the complete production time. So if we were able to, for example, produce wires not only manually, if we were able to produce and prefabricate them automatically, then we could spare a lot of this production time. And last not least, if we have the information necessary to produce wires automatically, to prefabricate them, we also have information to support the worker with the necessary information for the installation. That means connection points, wiring paths, torques, tools to properly install the wiring. Yeah, there's another one. You mentioned a study by the University of Stuttgart. Can one get this? Yes. However, the study currently is only available in Germany because it is related to the German market. But you can download it from our website, and therefore you have to enter our website www.eplan.de. You go to the section Company and News, and there you can download this study after a short registration. Okay, so if there are no further questions, I'd like to thank you for your participation, for your interest, for your time, and I'd like to wish you a pleasant fair so far. Hope to see you soon. Goodbye and have a nice day.